The tunnel under a volcano. Engineers heard something terrifying. Did you know that engineers are drilling a tunnel through an active volcano using enough concrete to build 30 Empire State Buildings? But that's not even the strangest part. Construction crews working 200 meters underground reported hearing mysterious rumbling sounds that don't match any known seismic pattern. Sounds that stopped exactly when drilling paused. But here's what engineers don't want you to know. If they miscalculate by just 2 degrees, they could trigger a catastrophic magma chamber breach that would flood the tunnel with 200-degree molten rock. So how exactly are they pulling off the impossible? And what happens if they fail? If you're fascinated by engineering marvels like this, make sure to hit that subscribe button and ring the notification bell. We dive deep into the world's most incredible projects every week. The Icelandic government faced a problem that seemed impossible to solve. Mount Hekla, one of Iceland's most active volcanoes, sits directly between Reykjavik and the country's eastern industrial corridor. Every time Hekla erupts, which happens roughly every 10 years, it cuts off the main highway for months, strangling the economy and isolating communities. The detour adds 6 hours to what should be a 90-minute drive. Talks of tunneling under Hekla date back over 4 decades. In 1981, engineers first proposed the idea and were laughed out of parliament. The volcano had erupted 20 times in recorded history. Politicians called it drilling into hell. Insurance companies refused to touch it. But Iceland kept losing $400 million every eruption cycle. The first serious attempt came in 1996. A team from Norway's tunnel expertise offered to drill a preliminary exploratory shaft. They made it 50 meters down before hitting a thermal anomaly. Underground temperatures spiked to 180 degrees Celsius, melting their equipment. The project died instantly. Cost $12 million down the drain. A second attempt in 2004 failed for different reasons. This time, political infighting killed momentum. Environmental groups sued, claiming the tunnel would destabilize geothermal systems that powered half of Iceland's energy grid. The lawsuit dragged on for 3 years. By the time courts ruled in favor of construction, global financial crisis hit. No funding, no tunnel. That changed in 2019 when everything aligned. The Icelandic Road and Coastal Administration secured a $2.8 billion funding package, half from the EU's Trans-European Transport Network, half from private infrastructure investors. But the real breakthrough was technology. Swiss engineers developed new thermal-resistant tunnel boring machines that could operate in temperatures up to 250 degrees Celsius. Suddenly, the impossible became possible. In March 2021, construction officially began. The timeline: 8 years to complete. The Hekla-based tunnel would run 32 kilometers through volcanic bedrock, emerging on the eastern slope 400 meters below the crater. It would be the world's first tunnel bored directly beneath an active stratovolcano. Engineers admitted they were entering unknown territory. No case studies, no precedent, pure engineering ambition backed by cutting-edge technology. What do you think about this ambitious vision? Drop your thoughts in the comments below. I read every single one. And if you're enjoying this deep dive, give this video a thumbs up to help others discover these incredible projects. The Hekla-based tunnel isn't just a hole through a mountain, it's a technological fortress designed to survive the planet's most hostile environment. The main bore measures 14 meters in diameter, wide enough to fit 4 lanes of traffic with emergency walkways on both sides. Total cost: $2.8 billion, making it Iceland's most expensive infrastructure project in history. Here's where it gets wild. Engineers designed the tunnel with a triple-layer protection system. First, they line the walls with 80-centimeter thick reinforced concrete mixed with volcanic ash, creating a heat-resistant barrier tested to withstand 300 degrees Celsius. Second, a 5-centimeter air gap circulates cooled air between the rock and inner wall. Third, an inner titanium aluminum composite shell reflects radiant heat back into the rock. It's like a thermos bottle built for cars. The tunnel features the world's most advanced real-time volcanic monitoring system. Over 400 seismic sensors embedded in the tunnel walls transmit data every 0.3 seconds to a command center in Reykjavik. AI algorithms process seismic waves, ground deformation, and temperature fluctuations to predict eruption events up to 48 hours in advance. If the system detects danger, automated gates seal both tunnel entrances in under 90 seconds, while alerts blast to every vehicle inside. Ventilation posed a nightmare challenge. You can't just pump air through a 32-kilometer tube under a volcano. Engineers installed 16 ventilation stations along the route, each powered by geothermal energy tapped from the very volcano above. The system cycles 2.4 million cubic meters of air per hour, maintaining internal temperatures below 25 degrees Celsius even when the rock outside hits 200 degrees. It's the most powerful civilian ventilation system ever built. Emergency protocols are equally insane. Every 500 meters, the tunnel features reinforced emergency bays, essentially mini bunkers carved into the rock with independent air supplies and communication systems. If an eruption happens while you're inside, you drive to the nearest bay and wait it out. Each bay stocks 72 hours of emergency supplies and connects to a separate escape tunnel system running parallel to the main bore. The lighting system uses low-energy LEDs that adjust brightness based on traffic density and outside conditions. During normal operations, they consume 60% less power than traditional tunnel lighting. But here's the crazy part. The entire tunnel generates more energy than it consumes. Geothermal heat exchangers built into the ventilation system produce 180 megawatts of electricity, enough to power 60,000 homes. The tunnel literally pays for its own operating costs by harvesting volcanic heat. Traffic capacity is designed for 8,000 vehicles daily, with plans to expand to 15,000 by 2035. The speed limit? 80 kilometers per hour, slow enough to maintain safety in the confined space, but fast enough to traverse the tunnel in 24 minutes. Compare that to the 6-hour detour. It's a game changer for Iceland's logistics and tourism industries. The tunnel also integrates smart technology throughout. Dynamic message signs every kilometer provide real-time updates on conditions ahead. Automated incident detection uses thermal cameras and AI to spot stopped vehicles or fires within seconds. Emergency response teams can reach any point in the tunnel within 8 minutes. The scale of this project is mind-blowing, but wait until you hear about the massive investment behind it. Before we dive into those numbers, which feature impressed you the most? Let me know in the comments. Breaking down the $2.8 billion price tag reveals where the money actually goes. Tunnel excavation and boring accounts for $1.2 billion, nearly half the budget. Those thermal-resistant boring machines don't come cheap. Each one costs $45 million, and the project uses 4 simultaneously. The triple-layer protection system adds another $680 million. That reinforced concrete mixed with volcanic ash, custom formulated and more expensive than standard tunnel lining. The titanium-aluminum composite inner shell alone runs $180 million. Safety and monitoring systems consume $420 million. Those 400 seismic sensors, the AI prediction system, automated gates, emergency bays. It's essentially building a volcanic early warning fortress. Worth it? Engineers say one prevented disaster pays for the entire system. Ventilation and geothermal energy infrastructure costs $340 million, but remember, those systems generate 180 megawatts of electricity. At Iceland's energy rates, they'll recoup that investment in 18 years, while the tunnel operates for 100+ years. The remaining $160 million covers administration, environmental mitigation, and contingency reserves. Funding sources split evenly. The EU's Trans-European Transport Network contributed $1.4 billion, viewing the tunnel as critical to Northern European connectivity. A consortium of private infrastructure investors, led by Swiss engineering firm Implenia and Norway's sovereign wealth fund, ponied up the other $1.4 billion in exchange for 30-year toll revenue rights. To put this in perspective, $2.8 billion exceeds Iceland's entire annual infrastructure budget by 340%. It's more expensive than Boston's Big Dig on a per-kilometer basis, but economic models project the tunnel will generate $8.2 billion in economic benefits over 30 years through reduced transportation costs, increased tourism, and industrial development in Eastern Iceland. The toll structure aims for $12 per passenger vehicle and $45 for heavy trucks. At projected traffic levels, toll revenue alone should hit $95 million annually by 2032, delivering healthy returns to private investors, while the government benefits from economic multiplier effects. As of October 2025, construction is 47% complete and ahead of schedule. Here's what's been achieved. The western portal entrance near Reykjavik is finished, a massive concrete structure that looks like a fortress gate built into the mountainside. Engineers completed it in September 2023. Tunnel boring has advanced 15 kilometers from the western approach and 9 kilometers from the eastern side. The 2 bores are expected to meet in December 2026. That moment, called breakthrough, will be a major milestone. The teams are currently 8 kilometers apart, But drilling through some of the most thermally active rock on the project, and here's where those mysterious sounds come in. In March 2024, drilling crews working on the western bore reported hearing deep, resonant rumbling that didn't correlate with their machinery or known seismic activity. The sounds happened intermittently, sometimes lasting 20 minutes, sometimes just seconds. What freaked everyone out? They stopped the exact moment drilling paused. Geophysicists investigated and discovered something incredible. The tunnel boring machines were hitting pockets of trapped volcanic gas under immense pressure. When drill heads pierced these pockets, gas escaped through microfractures, creating harmonic resonance in the rock, essentially the mountain singing as pressure released. Analysis showed the gas pockets pose no danger, but the experience rattled crews who thought they might be triggering something catastrophic. Temperature management has exceeded expectations. The thermal protection systems keep tunnel temperatures between 18 and 24 degrees Celsius, even in sections where surrounding rock measures 190 degrees. That's better performance than engineers predicted. The geothermal energy systems are already operational in completed sections, generating 78 megawatts from 16 of the planned 40 heat exchangers. The tunnel is already producing clean energy before it's even finished. Major contractors include Implenia from Switzerland handling boring operations, Iceland's own Istak overseeing concrete work, and Italian firm Geller managing the eastern approach. Coordination between three companies working in extreme conditions has been remarkably smooth, a testament to detailed planning and clear protocols. Testing of the AI monitoring system began in August 2025. Engineers simulated various volcanic scenarios to train the algorithms. The system successfully predicted 3 minor earthquakes before they happened, demonstrating the technology works as designed. One unexpected challenge: volcanic ash in the rock is more abrasive than anticipated, wearing down drill bits 30% faster than projected. This increased equipment costs by $40 million, but hasn't delayed the timeline because engineers stockpiled extra bits anticipating problems. The project currently employs 1 to 800 workers across 2 shifts. Safety record has been exemplary: 0 fatalities and only 12 minor injuries in 4 years. That's exceptional for such a hazardous environment and speaks to the rigorous safety protocols in place. Not everyone celebrates this engineering feat. Critics raise legitimate concerns that deserve attention. Environmental groups argue the tunnel disturbs geothermal systems that 180,000 Icelanders depend on for heating. Preliminary studies show minimal impact so far, but the real test comes when both tunnel bores are complete and fully operational. The bigger environmental question: what happens if they're wrong about Hekla's behavior? Mount Hekla is unpredictable. Its eruptions range from small lava flows to massive explosive events. The 1947 eruption was 100 times more powerful than the 2010 Eyjafjallajökull eruption that disrupted global air travel. If Hekla unleashes a similar event, could the tunnel survive? Engineers say yes. The design accounts for worst-case scenarios exceeding any historical eruption. But critics counter that worst-case scenario is educated guesswork. We've only studied Hekla for 1,000 years. The volcano is 6,800 years old. Who knows what it's capable of? Financial transparency has been another flashpoint. Iceland's National Audit Office raised questions about cost overruns in 2023. The original budget was $2.4 billion. It's now $2.8 billion, a 17% increase. Government officials blame inflation and the abrasive volcanic rock wearing equipment faster. Opposition politicians smell corruption, though no evidence has emerged. Local communities in eastern Iceland complain about construction disruption. Blasting operations crack building foundations. Truck traffic clogs small town roads. Dust from excavation causes respiratory issues. The government allocated $30 million for community compensation and infrastructure repairs, but many residents say it's insufficient. There's also the toll controversy. Many Icelanders believe a public road shouldn't charge fees. They argue taxpayers are subsidizing a project that private investors will profit from. The government counters that, without private funding, the tunnel wouldn't exist at all. Everyone benefits from improved connectivity, even if they pay a toll. Risk assessment studies published in 2024 identified several concerning scenarios. A major eruption could generate pyroclastic flows, superheated gas and rock traveling at 700 km/h. If a flow finds its way into the tunnel system before gates close, anyone inside dies. The AI prediction system aims to provide 48-hour warning, but Hekla has fooled volcanologists before with eruptions that started without typical precursor signals. Then there's the long-term maintenance question. The tunnel requires constant monitoring and upkeep. Thermal stress causes concrete to crack over time. Seismic sensors need replacement every 7 to 10 years. The AI system requires continuous updates. Who pays for this decades down the road? The toll structure includes a maintenance fund. But critics argue it's underfunded. One geologist I spoke with, who requested anonymity because they consult for the project, admitted uncertainty about one factor: magma chamber depth. Current models place Hekla's main chamber 10 kilometers down, far below the tunnel. But if secondary chambers exist closer to the surface, drilling could destabilize them. We won't know until we know, they said. Not exactly reassuring. Despite criticisms, the tunnel's transformative potential is undeniable. Start with economic impact. Construction has already created 1,800 jobs in a country of just 380,000 people. When operational, the tunnel will generate permanent employment for 250 people in maintenance, monitoring, and emergency response. Travel time reduction changes everything for Eastern Iceland. Cities like Egilsstaðir and Akureyri become economically viable for businesses that previously couldn't justify the logistics costs. Early estimates suggest the tunnel will attract 600 million in new investment to the east by 2035. Industrial facilities, tourism infrastructure, housing development. For Iceland's tourism industry, this is massive. The country attracts 2.3 million visitors annually. Most never venture beyond Reykjavik and the Golden Circle because Eastern Iceland is too far. The tunnel makes the entire country accessible. Tourism economists project an additional 800,000 annual visitors to eastern regions by 2032, generating $340 million in annual revenue. Emergency response capabilities improved dramatically. During the 2010 Eyjafjallajökull eruption, eastern communities were cut off for weeks. The tunnel provides reliable access regardless of volcanic activity, potentially saving lives during future eruptions. Energy production from the tunnel's geothermal systems adds 180 megawatts to Iceland's grid, enough to power 3 new aluminum smelters or a major data center complex. Tech companies are already in discussions about locating server farms in eastern Iceland, specifically because the tunnel's energy production makes it viable. The project establishes Iceland as the global leader in extreme environment infrastructure. Norwegian, Swiss, Japanese, and Chilean engineers have visited the construction site to study techniques applicable to their own challenging projects. Iceland is exporting tunnel boring expertise and thermal protection technology worldwide. National pride matters too. For a small nation, completing the world's first under-volcano tunnel announces Iceland as a serious player in global engineering. It's like Iceland's version of the Panama Canal or Channel Tunnel, a project that defines a country's capability and ambition. Climate resilience is another benefit. As climate change makes weather patterns more unpredictable, surface roads become less reliable. The tunnel provides guaranteed transit regardless of storms, flooding, or volcanic activity. That reliability is increasingly valuable in an unstable climate. The tunnel also enables grid connectivity between western and eastern Iceland's power systems. Currently, they operate semi-independently. The tunnel carries high-voltage transmission lines that will integrate the national grid, improving energy distribution efficiency and enabling Iceland to export more renewable energy to Europe via planned undersea cables. Social connectivity improves too. Eastern Icelanders have long felt like second-class citizens, isolated from the capital's opportunities. The tunnel reduces that psychological and practical distance. Families can visit more easily. Students can attend Reykjavik universities while maintaining ties home. It's not just about economics, it's about national unity. The tunnel is scheduled for completion in December 2028. If they maintain current pace, and engineers are confident they will, the first vehicles will drive through in January 2029, after 6 months of safety testing and systems commissioning. But this is just phase 1. The Icelandic government has already approved Phase 2, a second parallel tunnel for emergency use and additional capacity. Construction begins in 2032, with completion targeted for 2038. That second bore will cost another 1.8 billion, but will double capacity to 30,000 vehicles daily and provide true redundancy. If one tunnel closes, the other remains operational. Phase 3 gets really ambitious. Plans call for underground rest stops, maintenance facilities, and even a visitor center built into caverns excavated off the main tunnel. Imagine a rest stop 200 meters underground beneath an active volcano with viewing windows into the volcanic rock. Tourism officials are practically drooling. There's talk of connecting this tunnel to a broader network. If Iceland tunnels under Hekla, why not under other volcanic obstacles? Preliminary studies are underway for tunnels beneath Katla and Eyjafjallajökull. By 2050, Iceland could have an entirely underground highway system immune to volcanic eruptions. The technology developed here will influence projects worldwide. Japan is watching closely for application in Mount Fuji transportation corridors. Chile wants to apply these techniques to tunnel through the Andes. Even Hawaii is studying whether similar approaches could protect infrastructure from Kilauea's frequent eruptions. Will the tunnel succeed long-term? That depends on Hekla. If the volcano behaves within predicted parameters, the tunnel will operate operate safely for a century or more. If Hekla surprises everyone with a catastrophic eruption that exceeds design specifications, we'll learn a harsh lesson about nature's power. But here's the thing, engineering is about calculated risk. Humans have always built in dangerous places, cities on fault lines, skyscrapers in hurricane zones, tunnels under oceans. The Hekla Base Tunnel represents our latest attempt to outsmart nature using technology and ingenuity. 3 years from now, you'll be able to drive under one of Earth's most active volcanoes in climate-controlled comfort, powered by the very heat that makes the journey dangerous. That's either humanity's greatest triumph over nature or our most audacious act of hubris. Time will tell which one it is. What's your take on this mega project? Do you think it's worth the investment, or are the risks too high? Share your thoughts below. I love hearing different perspectives. Thanks for watching, and I'll see you in the next one.